All right, today we're diving into something pretty wild, a concept that could completely flip the script on air travel. We're talking about a long-haul jet built for a future without fossil fuels. Let's get right into it. So, what if a jet could fly like a glider? I mean, just picture it. A huge, wide-body plane just gliding through the sky with the kind of efficiency you only see in those sleek, high-performance sailplanes. Sounds a bit like sci-fi, right? But that's the actual idea behind this crazy new design. And you might be asking, okay, but why? Why would we even need something like that? Well, it all comes down to a really big problem. You see, commercial aviation is kind of stuck between a rock and a hard place right now. It's facing this huge environmental and economic challenge, one it just can't kick down the road anymore. Think about it. Right now, modern air travel is completely hooked on kerosene. And that's a double whammy. Not only does it pump out a ton of CO2 and NOx emissions, but it also chains the entire airline industry to the crazy ups and downs of the fossil fuel market. Plus, you've got the looming threat of carbon taxes. The bottom line here is that change isn't just a nice to have anymore. It's becoming totally necessary. And this is where our concept, the HYDRA Platform, enters the picture. Look, this isn't just about a small tweak here or a slightly better engine there. No, what's being proposed is a total game changer, a real paradigm shift for how we fly. Yeah, I really want to drive this home. We're not talking about taking baby steps. This is a ground-up, back to the drawing board rethinking of what a passenger jet even is, from the fuel in its tanks all the way to the shape of its wings. And this chart, it lays it all out, plain and simple. Just look at the comparison here. You've got today's heavy hitters, the Boeing 777X and the Airbus A350, right next to the HYDRA. Kerosene? Nope, HYDRA uses liquid hydrogen. Regular old turbofans? Swapped out for a new kind of electric system. And that standard wing design we're all used to? Gone, replaced with something totally different. So let's break down what this all actually means. Okay, first things first, let's talk about the heart of this beast, its engine. The entire HYDRA concept is built around what is pretty much the cleanest fuel we have. And that fuel is liquid hydrogen, or LH2 for short. Now here's the magic trick. When you use it in this proposed system, the only major thing that comes out the back is water. That's it. We're talking zero CO2, zero NOx emissions while it's flying. It completely cuts the cord between aviation and fossil fuels. Just gone. So you're probably wondering, how does that even work? Well, it's basically a three-step dance. First, you take that liquid hydrogen fuel and feed it into something called a ceramic solid oxide fuel cell, a CSOFC stack. Think of it like a power generator. That fuel cell then churns out a whole lot of electricity. And finally, that electricity powers the engines, which are these super advanced, high-temperature, superconducting electric turbofans. The end result? A totally electric propulsion system. But here's a really cool side effect that affects all of us. This new engine design means they can get rid of the super noisy gearbox you find in today's jets. And the result of that? The plane gets a lot quieter. We're talking a reduction of 10 to 15 EPNdB. Now, that might just sound like a number, but trust me, that is a massive difference. It's quieter for you in the cabin, and it's way quieter for anyone living near an airport. Okay, so that's the power. Now let's talk about that crazy shape and how it makes the plane so efficient. All right, this might just be the most eye-popping part of the whole design. The secret sauce to HYDRA's insane efficiency? It's the wings. And they didn't get the idea from other jets. Nope, they looked at high-performance gliders. The magic number to remember here is 18.5. That's the wing's aspect ratio. Basically, it's just a fancy way of saying how long and skinny the wings are. To put that in perspective, your typical airliner has an aspect ratio somewhere between 8 and 10. So yeah, 18.5 is just unheard of for a plane this size. And that's the key to what the designers are calling the glider effect. And you can really see the difference here. A normal airliner wing is all about compromise, right? It's trying to balance lift, strength, and speed. But the HYDRA wing, it's a specialist. It's laser focused on doing one thing perfectly, getting the most possible lift while creating the least possible drag. This all boils down to a term called the lift-to-drag ratio, or L/D. The easiest way to think about it is like gas mileage for an airplane. The higher that ratio, the better its mileage is. It means the plane is just slipping through the air super efficiently, so it needs way less power and less fuel to stay up. And this wing design, it's promising a massive jump in that number.
Okay, we've got space-age fuel and a space-age wing. You'd think the third big innovation would be even more high-tech, right? Well, you'd be wrong. It's actually surprisingly old school. It's a very intentional decision to look backward to make the plane safer.
Now, to really get why this is such a big deal, you have to know how modern jets work. Pretty much every single one of them, your Airbuses, your Boeings, they're all fly-by-wire. That means when a pilot moves the controls, they're not directly moving the flaps and rudders. They're telling a computer what they want to do, and the computer actually flies the plane. Hydra throws that whole idea out the window. Instead, it uses a hydromechanical system. What that means is there are actual physical cables and hydraulics connecting the pilot's stick and pedals directly to the control surfaces on the wings and tail. So why on earth would they do that? Well, it's a direct pushback against being 100% reliant on computers. By having that physical link, the primary flight controls are completely immune to a cyber attack. You just can't hack a cable. And it's not just about security. Pilots actually get a better feel for the airplane. They can sense what it's doing through the controls. Plus, when things go wrong, a mechanical failure is usually a lot more predictable than some bizarre, deep-in-the-code software bug. Now, sure, there's a small electronic system to help with stability and trim, but the core control, that's always directly in the pilot's hands. It's this really interesting mix of a futuristic plane with old-school, battle-tested reliability. So let's step back for a second. You take the hydrogen power, you add that super efficient glider wing, and you pair it with these tough, resilient flight controls. What does that all add up to? Well, you might just be looking at a blueprint for the future of flying. I mean, look at this. It's a design that stares down the airline industry's biggest problems and offers real answers. You've got a roadmap to zero emissions, you have a huge jump in efficiency, you have a plane built to be tough and resilient, and you have a business model that finally unplugs from the crazy world of fossil fuel prices. Now, let's be real. Even the designers admit this is a high-risk, high-reward play. It is an absolutely massive engineering challenge to build a wing that long and that light that can still hold up on a commercial jet. But if they can pull it off, the reward would be just as massive. And all of this leaves us with one heck of a question, doesn't it? Is this the kind of aircraft that will define the next century of flight? You know, concepts like HYDRA, they force us to completely tear up our assumptions about what's possible. Sure, it's a huge gamble, but it might just be the kind of bold, audacious thinking we need to figure out what flying looks like for the next 100 years.